What is going on, you lovely, lovely people? Welcome to the first video of GROG Teachers. This first lesson will be on alkanes / hydrocarbons. Now, before we get started with the first four hydrocarbons / alkanes, this is the rule of alkanes, let's say. Get out of here, dug the bug. Anyway, so pretend you've got a carbon, right? A C, right? So you've got a C. Now, in maths, you have the powers on the top. So like, let's say 2 squared, it's going to be 4. But in science, this is about chemistry, we've got, so let's say your C, and let's say your power, so that's going to be on the bottom instead of the top. So let's say your power is going to be N, right? Then you have your hydrogen, so hence the name hydrocarbon. Since your carbon is going to be saturated in hydrogens, you're going to want a 2N next to it. So you have CnH2n for double your carbon, but it's not done there. You've got a +2. So when you double it, when you double your carbon for your hydrogen, you want to add 2 to the end. So you get a complete hydrocarbon. So the first hydrocarbon is methane. So that's CH4. So C is going to be, imagine an invisible 1. So C1H4. Double 1, you get 2. Add 2, you get 4. Hence the name. Well, hence the formula. CH4, doubling it for 2, adding 2 for 4. So I'll try to draw a diagram with it with my hand, hopefully. So say you have a C here, a C. Draw 4 sticks going off it. This is a stick diagram. You have a H here, H here, H on the top, H on the bottom. So carbon's like connecting to 4 stuff, whereas hydrogen's only like collecting 1. Or connecting to, no, bonding. So carbon's like bonding to 4, while as hydrogen's only like bonding to 1. So that's methane. Next is ethane. Ethane is C2H6. So you got the 2, add, no, 2, double it for 4, add 2 for 6. Okay. So what it looks like is C, line, line. So the C's are connected to 4, and the carbons are connected to 1. So there's the rule again. Carbon 4, hydrogen bonds to 1. Propane now. Propane is C3. I've got it written down. C3H8. So, you know, C3, double 3, 6, add 2, 8. And then, so basically, like before, C, C, C. Then your H is drawn around it. So middle connects to the 2 C's at the end. Your 2 carbons connect to the middle carbon to create 4. Now, Now we get onto the bigger hydrocarbons I've written down on my piece of paper. So you'll see me like lifting my head up a bunch. Now, on to... Was it decane I wrote down? No, it's butane next. Sorry, butane. Butane... GCSE, the only one to have the first 4 alkanes / hydrocarbons. So, methane, ethane, propane, butane. Now, butane is, as before, C4H10. Since, like the rule, double it for 8, add 2 for 10. And you know, 4 carbons, yeah, hydrogens all around, so carbons connect to 4, hydrogens connect to 1, bond to 1. Now, we're on to decane. Now I'll start lifting this up more often. So bear with me. I've got some facts now for some of them. Yep. Decane now. Decane. So, pretend a decagon. 10 sides. I'm pretty sure you know now. C, 10, dec, 10, decagon, 10 sides. Double it for 20, add 2 for 22, so C10, H22. Decane is used in gasoline and petroleum. And another little fact. The longer a line of, a chain of hydrocarbons get, the less reactive they become, since it has to travel down the line. So methane will be the quickest. So say like some methane. Right, so say you do something with methane, right? Straight, almost instantaneous. Whereas decane will take a bit longer, since it's a longer chain. Anyway, on to more. Now that I've explained the whole, basically. Next one is undecane, so C11H24. Double it for 22, add 2 for 24. Now, undecane is used as a solvent, fuel component, and industrial use / a component in kerosene. As before, same thing, 11, 24. Now, I don't really have a lot more to comment on the rest of the, alkanes / hydrocarbons. I don't know if it's dodecane or dodecane. Anyway, dodecane C12. Is it H26? H26, yes. Double it for 24, add 2 for 26. Now, dodecane is used as a solvent. No, I got it wrong. So, undecane is used in skincare and cosmetics. When I said it was used as a solvent, fuel component, an industrial work / component of kerosene, that was dodecane. So undecane, skincare and cosmetics. Dodecane is fuel component, industrial, and component in kerosene. Okay, now I've cleared that. Tridecane. C13H28. So you have 13, double it for 26, add 2 for 28. Okay. Saying this too much, but I want to get it through everyone's head. Now, I didn't write a lot down about tridecane, but it's used as a fuel solvent? Yes. It's used as a solvent and in fuel research. No, I didn't write a lot about it, so I'm not going to go into specifics. I'm already 10 minutes, nearly 11 minutes into this. Now, the last one I've written about before I end it is called hectane. It's the largest one on my list. And, you know, it's C100H202. Double it for 200, add 2 for 202. Now, this one would be the longest one I've written down since 100 carbons and 202 hydrogens. This is where something new gets introduced called, I'm going to have to say this, aren't I? Kraken. So, when a hydrocarbon's too long, okay, it will, you know, as I said before, react much slower. So then, people will have to do something called Kraken to then split it in half, then have a faster reaction out of it. So, if you crack hectane, you'll get C50H101 since you're splitting down the middle, so you have, an equal part each side. Now, hectane is used in an additive to paraffin waxes and petroleum jelly. It's used to heighten their melting point. What else did I write? Yes, to adjust their melting points, hardness and consistencies, since, you know, it's a long chain, it'll take long. Now, hopefully I can make more stuff like this to, you know, explain more better. But that has been GROG Teachers on alkanes / hydrocarbons